Hello everyone and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some exciting AI research. We'll be looking at a paper called Seg-Zero Reasoning Chain Guided Segmentation via Cognitive Reinforcement. This paper introduces a really interesting framework for getting AI to segment parts of an image based on complex reasoning. The challenge with older methods is they often don't generalize well to new situations, and they don't explain their reasoning. Seg-Zero tackles this using two models, one for reasoning and one for segmentation trained using reinforcement learning, which helps it generalize better and even show its chain of thought. Okay, so figure 1 here gives us a nice visual of what we were just talking about. You can see how Seg-Zero generates this reasoning chain, like identifying the player by thinking about the baseball uniform before it actually creates the segmentation mask. This is different from just directly segmenting. And the bar charts on the right show the performance. Reinforcement learning really shines compared to supervised fine-tuning, especially on those out-of-domain tests, proving it generalizes better like we discussed. Adding the chain of thought helps even more. Okay, so figure 3 here dives a bit deeper into the architecture we've been discussing. It clearly shows those two separate parts, the multimodal MLLM for reasoning, which is trainable, and then the segmentation module, which actually generates the mask using frozen components. You can see how the reasoning model outputs that structured thought process within those think tags, and then provides the final answer with the bounding box and points to guide the segmentation. This figure also details the reward function for the reinforcement learning, showing how it checks both the format of the output and the accuracy using things like IOU and distance metrics. Okay, so building on that comparison between reinforcement learning and supervised fine-tuning, Figure 5 really drives home a key point about preserving general abilities. We see here that SFT, while maybe okay for the specific segmentation task, actually hurts the model's performance on general visual question, answering tasks like chart VQA and text VQA compared to the baseline. It forgets its other skills, but look at the RL methods. They maintain that baseline performance really well, showing that reinforcement learning avoids that catastrophic forgetting problem. Adding the chain of thought seems to help slightly too. Okay, so figure 6 gives us some really nice visual examples of Seg-Zero in action. We've talked about the reasoning chain and the segmentation. Well, here you can actually see it for different kinds of user prompts. Look at how the model thinks through the question, like identifying the conductor based on position and clothing, or figuring out which part of the cave to explore, before highlighting the correct area or object. It really shows how that step-by-step thinking helps it handle these complex requests accurately. Okay, and figure 9 here just gives us some more really solid visual examples, similar to what we saw in figure 6. It again shows that thinking process, like figuring out what a hockey stick is used for based on the query, or identifying a child's favorite toy like the teddy bear, or even finding something protective like a knee pad. It just further demonstrates how that step-by-step reasoning helps the model accurately segment the right object for these varied user requests. So those examples really highlight the power of Seg-Zero. I think the key takeaways are how reinforcement learning, guided by that cognitive reasoning chain, enables impressive zero-shot segmentation for complex prompts. And critically, it does this without forgetting general visual skills. It's a promising step towards AI that can truly understand and act on nuanced instructions like we do. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm your host, Alex.